Alright, welcome to this week's video. We're going to be looking now into a LeetCode challenge, and that's going to be number 1346. That is check if n and its double exist. That's an easy problem, and it's going to be a problem about arrays. So the challenge says, given an array R of integers, check if there exist two indices I and j such that I is different than j, I and j they're greater than 0 but less than the length of the array, and the number that I is pointing to is 2 times the number that j is pointing to, right? So we're looking for whether two indices exist such that the number that they're pointing to is twice as much as the other one. So for example, here we have example 1, we have 10, 2, 5, and 3. We can right away see that 10 is 2 times 5, so we're going to return true in this case. And in this example here, there's no two numbers such that they are twice as much as the other one. And for that reason, we return false, right? So the first thing we can do here is to actually start with the worst solution. That's going to be a brute force solution where we look for every pair in our array and then check if they are twice as much as the other one or half as much, because if one is half as much as the other, then by default the other one's going to be twice as much, right? So we're just going to be looking now for every single possible pair and then trying to see for that condition. Okay, so let's now here first define a variable n. That's going to be the length of my array. And we're going to now be looping through this array twice, right? For each element, we're going to be looping this once again. So for I in range here n, we're going to be now looping once again for j in range. But now we don't have to start from 0 anymore. We can actually start from I plus 1. So we're going to be starting from I plus 1 all the way to n. And that is because we're not allowed to check for the same number. I is different than j. So that's why we put a plus 1 here, because we're checking everything after this I. So every single pair is going to be included over here. And now we simply need to check whether that condition exists where one number is twice as much as the other. So if Ri, if that's going to be equals to R of j and then times 2, right? That's one of the conditions. Or the other case is if Ri is going to be equal to Rj divided by 2. And that is because it doesn't matter the order, right? So if one exists that's half, that implies that one is twice as much as it. So both of these cases here account for the condition here, that the array of j needs to be twice as much as the R of I. And if that's the case, we know we found a pair, so we return true. However, if we go through all of these loops and we didn't find anything, then we got to return here false. So let's see how this does. This actually is O of n squared, because for every single element, we're looping through the list all over again just to find every single pair. That's why you only beat here 14% of the solutions. Now we can do a better job than this, and that we can do everything in O of n time complexity, which means that we only need to loop through that array once to find that solution, right? So we're going to start here with n. We're just going to calculate the length of our array. But now the key point here is to actually use a set, right? So a set is a data structure that allows you to read elements from it to check if they exist in O of constant time, O of 1. So these are very fast operations, and it's going to allow us to save data as we loop through that list, and then check to see if for a given number, if the double amount is already in that set, or if half of its amount is already in the set. So we're going to be looping through the list once. For every element, we check whether it's double or it's half, it's already in the set. If it is, we know we found a solution, so we return true. Otherwise, we just add the current element to our set. So let me show you how that works over here. So we're going to do here for I in range n once again. We need to check for every element if it's double or it's half, it's already in the set. So if Ri times 2, if that's in S, right? Or if it's half, it's in S. So if either it's double or it's half, it's in the set, we know we found a pair, so we return here true. However, if it's not, we just want to add the current element to the set and continue our search. So we're going to be doing s.add our current element, RY. And that's pretty much it. So if it goes through all that process and doesn't find anything, we can simply return here false, because we know there's no solution. So let's submit that and see how it does. And you see here now we do much better. 63% now of the solutions are B. And that is because we're now solving the same problem in O of n time. But that's pretty much what I had for this video. Thanks for watching, and I see you next time.